Hi everyone, Jack from Maths Forge. In today's lesson, we're going to be doing fractional and negative indices. So let's take a look at our first example. Here we're being asked to find the value of 2 to the power of 0. So something you need to know and understand is that anything, any number, any variable to the power of 0 is equal to 1 by default. And if we check our answer, there it is. And the explanation behind this is as follows. If I have any number to the power of a certain number divided by the same number with the same power, well, of course, if you're dividing the same base, then you subtract their powers. So, of course, this is going to give us 2 to the power of 3 minus 3, which is 0. And we know as well in mathematics that if you divide any number by itself, it gives you 1. So, of course, 2 to the power of 3 is 8, and 2 to the power of 3 is 8. And of course, 8 divided by 8 is 1. So therefore, anything to the power of 0 must be equal to 1, because of course, this applies to all numbers. And that's the idea behind it. And we'll do another 1-star example. Anything to the power of 1 is itself. So 8 to the power of 1 gives you 8. And of course, x to the power of 1 will give you x. A million to the power of 1 will give you a million. And if we check our answer, there it is. Let's do a 2-star example. Here we're being asked to find the value of 2 to the power of negative 4. And how you approach this question is as follows. Anything with a negative power causes the base to drop to a denominator. So like this. So we have 2 to the power of negative 4. The negative part of the power hits the 2, causes it to become a denominator, and then the power becomes positive. And then what are you left with on top? Well, you're left with the number that's being multiplied to the 2, the number in front of it. And since there's nothing, then it's just 1 times this number. So it's just 1. And of course, if we had, as an example, 3 times 2 to the power of negative 4, well, of course, the final answer here will be over 2 to the power of positive 4. So the negative part of the power causes the 2 to drop down to a denominator. And on top, we'll be left with whatever multiplying to the 2 to the negative 4 in front of it, which is 3. But in this case, we're just given a very straightforward question of 2 to the power of negative 4, which simplifies to 1 over 2 to the power of 4. And of course, 2 to the power of 4 is 2 times 2 times 2 times 2, which gives us 16. So 1 over 16 should be our final answer. And if we check it, there it is. And the understanding behind this technique comes from the following. So I've written a sequence of numbers, and it is the sequence with a base of 2 and the powers are climbing up by 1 each time. So of course we know 2 to the power of 4 is 16, 2 to the power of 3 is 8, 2 to the power of 2 is 4, 2 to the power of 1 is 2, 2 to the power of 0, or anything to the power of 0 is 1. And as we get into the negative powers, just take a look and see what's happening to the numbers in your sequence as you go to the left by 1. Every time we go to the left by 1, the numbers are halving. They are dividing by 2 each time. And so we can deduce that this is going to keep on happening. So if we move to the left by 1, what do we end up with? Well, a half of 1 is just a half. So of course, 2 to the power of negative 1 must be 1 over 2, because that's a half of 1. And if we go to the left once more, and we half a half, well, half of a half is 1 over 4. And if we keep doing this, we end up with 1 over 8 and 1 over 16. And you can see immediately the relationship here, that the denominators here for the negative powers are the same as the numerators here for the positive powers. And so that's how we were able to come up with a technique through pattern recognition that if you have a negative power, it's the same as having your base number drop to the denominator and take the positive power. Because of course 2 to the power of 4 is the same as 16. Now let's do a 3-star example. Here we're being asked to find the value of 27 to the power of 2 over 3. So we have 27 to the power of 2 over 3. What you should know about fractional indices is that the numerator in the fraction of the power acts as a regular power. So this is to the 27 to the power of 2. And the denominator in the fraction of the power acts as a root. So this is the cubed root of 27. And now, of course, you have the question, well, okay, if the numerator acts as a regular power, so it's 27 squared, and the denominator acts as a root, so it's the cube root of 27, which one do you do first? Well, it doesn't matter which one you do first. In fact, the one you should do first is the one that is easier to calculate for you personally. So my personal approach to this specific question, rather than having to do 27 squared, so 27 times 27, I know that the cubed root of 27 is just 3. So I'm going to go ahead and do the cubed root of 27 first. I'm then going to follow up with the power, the square, and then I'm going to do that next. And of course, I'm using brackets to show that I'm going to do the cubed root of 27 first, and the square's waiting on the outside to square whatever's left over after I do the cubed root of 27. So the cubed root of 27 is 3, and then there's a square waiting on the outside. 3 squared is equal to 9. And that should be our final answer if we check it. There it is. And that's really it for fractional negative indices. Remember that for negative indices, your base number drops to the denominator and the power becomes positive. And for fractional indices, the numerator in the power acts as a regular power and the denominator acts as a root.